In this lesson, we'll talk about one of the foundational concepts on the GMAT-focused quantitative reasoning section, which is what are abstractly defined as number properties. So let's just talk about how numbers are defined in English and arithmetic ultimately. So an integer is a numeric value with only zeros after the decimal point from a technical perspective. Now, a divisor or factor is a number that divides into another number evenly. So, for instance, 4 would be a divisor or factor of 12. A multiple, however, is a number that multiplies from another number. So, 24 would be a multiple of 12. And this distinction is one of the foundational things for the exam, just making sure that you try to avoid confusing divisors and factors with multiples. And we know from just a numeric definitional perspective, the largest factor of any number is equal to the smallest multiple of that number, which is the number itself. And we can test this with 12, right? Because largest factor of 12 is 12. The smallest multiple of 12 is 12, 12 times 1. And of course, 12 itself is 12. One of those foundational things that's deconstructed that you probably haven't thought about in a long time, if ever. Our four basic functions are defined as such. The sum is a result of addition. The difference is the result of subtraction. The product is a result of multiplication, and your quotient is the result of division. Now, evens and odds are another concept that, from a almost logical perspective, the exam likes to exploit. So first, we just have to define what an even integer is, and that's an integer that's divisible by 2, because you could split it into 2 even halves. An odd integer is defined by what it is not. It is an integer that is not divisible by 2. 0, however, is even, because the technical way to determine whether something is odd is if it has a remainder of exactly 1 when divided by 2. So 0, when divided by 2, the quotient remains 0 because 2 goes into 0 0 times and there's nothing left over. So again, just kind of how philosophically this gets to that answer or that statement that 0 is always even. Now, when you're computing evens and odds, there are some combinations that are known to always have consistent outcomes in terms of the result being even and odd. Firstly, only a sum or difference of an odd and an even will be odd. So 5 minus 4 is odd. 5 plus 4 is odd. If you combine two odds like 5 and 3, you get an even because the two leftovers become one pair. If you combine evens and evens, there's nothing left over. It was always even. It will remain even. Now, the sum or difference of two evens, as we just said, is even. The sum or difference of two odds is also even because the one left over makes a new pair. The product of two evens will remain even as well. The product of two odds will remain odd. But an even when it comes to products is like an unwanted house guest. It never leaves. So the product of an odd and an even becomes even. You can test that with 3 times 2, 6 is now even. There aren't any consistent rules that we really want to go into as far as quotients go, because remember that your quotients may or may not be integers depending on the factors that are within your numerator and denominator when combined. Now, let's just talk about some properties of the unique integer 1. So the product of any value and 1 is itself. So 12 times 1 remains 12. The quotient of any value other than 0 divided by 1 is itself. So it's just going to remain that thing. So if you had 12 divided by 1, it's 12. And it's just staying that way forever. Quotient of any value other than 0 divided by itself is 1. So if you divide 12 by 12, you get 1. Again, unique thing that just happens for every number, because 72 divided by 72 is 1, negative 33 divided by negative 33 is 1. It's just how it works, that the thing itself will always divide into itself one time. The implicit exponent or power of any value is 1. So if you see a 10 written down, that's really 10 to the first power. It's 10 times 1. Now some properties of 0. So 0 is the only non-negative and non-positive value. Adding or subtracting 0 from any value results in no change to that value, so it just stays the same. So 5 plus 0, 5 minus 0 remains 5. The product of any value in 0 is 0. So that means that 12 times 0 is 0. So 0 is a multiple of every number because any value multiplied by 0 gives you 0. But you are not allowed, for the purposes of this exam, to divide anything by 0 because the technical result, if you divided 12 by 0, is actually infinity. It's non-real. And for the purposes of the GMAT, division by 0 is not defined and really not allowed by the structures of the arithmetic that the exam uses. This is good news. We don't want to be dealing with infinities, and we don't want to be dealing with imaginary numbers either. So an absolute value is the distance from 0 on the number line. So that's what absolute value technically measures, is how far something is from 0 on that number line. And 0 is the center point of every number line. So your absolute values will always be greater than or equal to 0. For instance, the absolute value of -4 with those two vertical lines indicating absolute value is 4 because -4 is 4 units from 0 on the number line. And as I was saying, all GMAT math is real. So you could see a little number line here with 0 in the center and some what are known as irrational terms, including pi. Even though geometry is not explicitly tested on the exam, pi might come up as a concept because it is an irrational number, and the exam does like to test the abstract notion of a number that doesn't fit within our decimal paradigm, such as pi, such as the square root of 2 or 17, as we see here on the chart there. So are real numbers defined? They can be expressed as a value on the number line, whether they can be expressed as a fraction or not, as an integer or not. So rational numbers can be expressed as fractions, for instance, 1/2 or 1/3. That's what is known as a rational number because it has a numerator and a denominator, and some sort of repeating pattern in its structure decimally. Irrational numbers, however, cannot be expressed as fractions. So those are things like pi or the square root of 2. And you will only convert irrational numbers to decimal if the problem is asking you to approximate. Most usually, you are going to want to remain in the format of the irrational value because your answer choices will reference pi if it's being used, will reference the square root of 2, the square root of 3 if it's being used, as a value that is basically going to need to be converted as a last step or just compared conceptually. So some of those approximations you may encounter, may need things like pi is 3.14 approximately, the square root of 2 is approximately 1.4, and the square root of 3 is approximately 1.7. You can think about the saints' days if you're familiar with the United States calendar or a similar Anglophile calendar. Square root of 2 is St. Valentine's Day, February 14. St. Patrick's Day would be March 17, if that's a helpful mnemonic for you. And you want to compare irrational values to rational ones to convert on the number line. So for instance, if I was trying to figure out what the square root of 17 was, well, I know that it has to be just a little bit above 4 because the square root of 16 is 4, and square root of 17 has to be bigger than the square root of 16. And usually with these irrational values, the exam is primarily going to be desiring you to combine to get two rational values or compare them against rational values logically. So let's head on over to the whiteboard and take a look at an example problem involving something that we might need to compare using these number properties. So we set up our scratch work. We've got A, B, C, D, E, put a little line over top, and we're being asked for which is furthest from 0 on the number line. And looking at our answer choices, we got everything using that square root symbol. So that just means greatest, basically, since they're all positive values. Now, you may be thinking to yourself, well, how am I supposed to know what the square root of 10, the square root of 5, the square root of 8, the square root of 2 are? And you're not. But we know that we can apply the same operation to everything and maintain our comparison. So we're just going to get to the square for each of these. And then the value. once it's squared. So if we were to square 2, that would be 4. And if we square the square root of 10, that's going to be just 10. So now our value is going to be 40. I don't know whether that's bigger or smaller yet. I've got to compare everything else, but right now, that's a starting point. So then the next one, we've got 3 times the square root of 8. So the square here is going to have to be 9 times 8. And of course, 9 times 8 is going to be 72. And that is well greater than choice A. So choice A is now out. Then we've got 4 times the square root of 5. So again, we'd square both values. So we have now 16 times 5, and that gives us 80. And 80, of course, is bigger than 72. So we can now keep C as the leader for now. Then we've got 5 times the square root of 3. So the square of 5 is 25. And then the square root of 3 squared would be 3. And it's close, but that's 75, so that's out. And we'll keep choice C for now. And then the last one we've got is 6 times the square root of 2, which would be 36, times 2, which would give us 72. And we can see now that choice C is the greatest of the options just by executing on a comparison logically by squaring everything. And remember, we're being asked for this kind of abstract, furthest from zero on the number line structure. So we've got a problem seeking an inexact value. So that's my clue that even within the construct of, say, number properties, which are really relatively technical in nature, this is a logical evaluation clue. Saying, hey, you probably don't need to fully calculate this thing, but think critically about how to answer the question in an efficient manner. So go ahead and practice your own number properties sets and other problem solving questions to improve recognition of how to answer even some of these more obscure kinds of questions and really just master this foundational aspect of your arithmetic review in advance of succeeding on the GMAT focus exam.